So we're continuing with basic integration rules. Now we're going to talk about antiderivatives of trigonometric functions. So let's start with sine and cosine. So let's say, for example, that we're looking for an antiderivative of sine x dx. So what is it equal to? So we're looking for a function such that the derivative of that function is sine x. So if we go over cosine x, we see that the derivative of cosine x is negative sine x. To offset that negative sign, we multiply by negative. So the antiderivative of sine x is negative cosine x. And of course, the way you verified it is by taking the derivative of the right-hand side, and you should get sine x. So that's one thing. And we cannot talk about antiderivative of sine x without mentioning that of cosine of x. So the antiderivative of cosine of x is sine x plus c. So sometimes we get confused with signs. So I came up with this table here for you guys to remember the derivative and antiderivative of sine and cosine. So you draw two perpendicular lines. On the horizontal lines, always cosine. So this is positive cosine, this is negative cosine x, and on the vertical line we have sine x, the positive side, and negative sine x, the negative sign. So if we are going clockwise, this means the derivative. So for example, the derivative of sine x is cosine x, the derivative of cosine x is negative sine x, the derivative of negative sine x is negative cosine x, and the derivative of negative cosine x is sine x. So yellow, that's the derivative. For the antiderivative, you go counterclockwise. So for example, an antiderivative of sine x is cosine x, is negative cosine x. So the white one is antiderivative, and an antiderivative of negative cosine x is negative sine x, and so on and so forth. So this little chart here can help you not get confused with antiderivative of sine and derivatives of cosines, for example. So the bottom line is these are the formulas that we're gonna, or the expressions that we're gonna use. Now let's use that and find an antiderivative of a function. And within this antiderivative, I'm going to introduce another property of integrals. So let's say you want to find an antiderivative of 5 cosine of x minus sine of x dx. Let's say you want to do that. Now, how does that work? The new thing here is, first of all, in previous videos, we've seen that, we have constant that multiply a function, and here we have a function. But we have the minus sign here. How do we deal with this minus sign? So whether you have plus or minus sign, you can split the antiderivative at that sign. So this becomes what? The antiderivative of 5 cosine of x dx, don't forget it, dx, minus the antiderivative of sine of x dx. So see, I split the antiderivative at the sign. So now I have two antiderivatives that I can manage. And we also saw that we can take out the 5 for this first So at the end of the day, you get 5. And what's an antiderivative of cosine of x? We just saw it up here. Is sine of x. So 5 times sine x minus, what's an antiderivative of sine x? We saw that is negative cosine x. So minus negative cosine of x. And of course, when you're done, you add the constant of integration. And we can simplify further. So 5 sine x, 5 sine x, and then minus times minus, that's plus cosine of x plus the constant c. So this here is the answer. So as a rule, when you have a plus or a minus sign somewhere, just go ahead and split at those points or at those signs. Let's go over another example to see how this works. Let's say we're given this function, so we want to find an antiderivative of x cubed minus 10x plus 5 dx, of course. Now, how do we do this? So how many functions are involved here? We have this function minus that one and plus this one. So we have 3 functions to work with. Now, by now we already know the rules. We know that if we have the minus or the plus sign, we're going to split it into 3 antiderivatives. So that means we're going to compute the derivative of x cubed and then compute the derivative of 10x, the antiderivative of 10x, and the antiderivative of 5. So what's the antiderivative? I'm just going to do it right away here. What's the antiderivative of x cubed? We use the power rule for integration. We get x 3 plus 1 over 3 plus 1. And then for the second part here, I'm going to write it in red. So we have minus. What's the antiderivative of 10x? It's just 10, but we have to be careful here. X, when you see x, x is which power? To the first power. So the antiderivative will be 10 times x, that first power, plus 1 divided by the same thing. And then lastly, we have minus 5, so minus 5. What's an antiderivative of 5? Is 5x. That was the first basic integration rule that we saw. And obviously, we add the constant of integration. So how does that work? We get x to the 4th over 4 minus 10 x squared over 2 minus 5x plus c. And of course, we can simplify the middle term here. 10 over 2, that's 5x squared minus 5x plus c. And of course, here you can always take the derivative and see that you have the original function. So this time around, what I did is I computed the antiderivative without writing splitting this into 3. Actually, I did it, but I didn't write it down. I didn't write x cubed dx minus 10, the integral of x dx, plus 5, the integral of 1, excuse me, dx, which you could do. But I imagine that you already know how to use the rules, so you can bypass it. But make sure that you keep track of the number of functions that you're taking the antiderivatives of, and also the appropriate rule that you are using.